Okay, in this video, we are going to have another look at an automotive sensor. Now, cars have a lot of sensors, and I like using them in my projects because they have a very robust enclosure, and they have an easy way to mount it. So this is the mounting hole, so we could put a bolt through there and a nut on the other side and mount that to your project. Now, this is a knock sensor, and it's bolted to the engine of the car, so it has to be weatherproof. It has to handle the cold winters and the hot summers. And inside this sensor, this knock sensor, is a piezo element like this. Now, if you want this piezo element and try to make it as robust as this, you'd spend a lot of time and money. I've actually encased these in epoxy, but by the time you get to two-part epoxy and make the mold, this is a much easier way to go. You just buy the sensor, it's got a cable, it's got a connector at the other end, you just bolt it to your project, and away you go. Okay, next, we are going to have a look at what knock is in an engine. Now, some people call it knocking or pinging or rattling. So here's a little demo. Now, if you have kids, you probably push them on a swing. So this pencil would be the swing, and this is you pushing them on the swing. So you'd push them, and it would go over, it would come back, and it would stop for a split second, and then it would just start moving back, and that's when you push. That's the sweet spot. So it comes back, it stops for a split second, just starts to move back, you give it a push. Now, if you would give it a push, now you'd run towards the swing, and the swing comes back, it would hit you and knock you over. That's basically what knock and pinging is in an engine. Okay, here's your typical 4-stroke engine that you have in your car. So we have the intake, compression, power, and exhaust. So in the intake stroke, the piston is coming down, it's pulling in fuel and air into the cylinder. Compression stroke, the piston is coming up, compressing that air-fuel mixture. And then the spark plug fires, it ignites the fuel-air mixture. Now when it ignites, we're going to get expanding gases, and the pressure will increase and cause the piston to come down. Now the sweet spot, we want the pressure to be maximum when the piston is just starting to come down. At about 14 degrees of the crankshaft rotation is when we want it to happen. Now on detonation, if we get pre-ignition or detonation, we actually get ignition when the piston is coming up, and we get pressure built up in the cylinder against the piston coming up, so we're butting heads, and that's when we get pinging or rattling in our car. Now it could be caused by a high compression engine with low octane fuel, could have carbon deposits, wrong air to fuel mixture, engine too hot, too much advanced timing, wrong type of spark plug. There's a lot of variables, but that's basically what happens when you hear pinging or rattling in your car. Okay, so the knock sensor is bolted to the engine of the car, and when the computer detects knock, it'll adjust some engine parameters to get rid of the knock. So I put a bolt through my sensor and a nut on the other end so I could hit on it. And I have it connected up to this little circuitry here, a little signal conditioning circuitry, which is driving this MOSFET transistor, which is connected up to pin 3 GPIO of my SCAMP board. And every time I hit it and it will detect knock, it's going to toggle this LED. So I have a hammer. So when I hit on it, watch the LED comes on. And if I hit it again, she'll go off. So every time I hit it, I'm getting a pulse into pin 3, about 50 milliseconds. You can see the scope. So when I hit it, you'll see a 50 millisecond drop, and that's going into GPIO pin 3, and it's being detected and toggling the LED. Okay, next, we are going to have a look at a real-world application. Now, a few years ago, I got a call from our local fairgrounds, and they have a dunk tank on the grounds, and they wanted to move the bullseye to different areas. Now, the bullseye was triggered mechanically to drop the person into the dunk tank, and they didn't know how to interface that. So I got a piece of plate metal, cut it into a circle, made a bullseye, and I bolted the knock sensor to it. So now when the ball hit the plate, the bullseye, it would trigger a monostable, which would be this LED. It will come on for 1 second, and it will pull in a solenoid like this. It would pull it in, and that would trigger the dunk tank, and the person would fall in. So now when I hit knock sensor, this LED will come on for 1 second. It's just basically a monostable circuit. So I'll hit it. It's on and off. So every time I hit it, I'm getting a 1 second output to drive the solenoid. Okay, here's the code running on the SCAMP board, and it's written in FlashForth. So the first word is toggle, so that's my test program. So a GPIO pin 5 is set up as an output, and that's connected up to the LED. Pin 3 is set up as an input with a pull-up, and that's connected to the open drain of my MOSFET. Then it goes into a begin until loop, so this is always running. So it's sitting in this loop waiting for pin 3 to go low. That's when we hit the knock sensor. Pin 3 will go low. When it detects that, it will jump out of the loop and toggle pin 5. That's the LED. Then it does some debouncing in case it's noisy, and it'll go back up to the beginning and do it all over again. So the next word is called dunk. That's for our dunk tank. So GPIO pin 5 is set up as an output. That's connected up to the solenoid. And we clear it, make sure it's low. GPIO pin 3 is set up as an input with a pull-up, and that's connected up to our open drain of our MOSFET. Then we go into a begin until loop, so it's running continuously in this loop. It's waiting for pin 3 to go low, so when we hit the knock sensor, pin 3 will go low. We'll detect that, come out of this loop. You'll set pin 5 high, it'll turn on the solenoid for 1 second, then it'll turn the solenoid off. And it does that in a loop continuously until we hit a key, and it'll come out of this program. Okay, here's the schematic diagram of the circuit that I built in my breadboard. Now the piezo knock sensor, the equivalent circuit, is a voltage source, AC voltage source with a series capacitance, and I got it in a dotted box. So when we hit the piezo knock sensor, we're going to get an AC signal. The negative half cycle is going to go through this diode and charge up the capacitor with plus on this side and minus on this side. Now when the piezo goes positive, we're going to get plus on this side and minus on this side. So these two are in series, so we're going to get a voltage doubler. So we're going to get double the voltage of V peak, and that's going to be fed and charge up this capacitor. So we're going to get a spike, it's going to go up high, then we're going to get a discharge to the 1 megohm resistor, and she'll come down on the discharge. So she's going to trigger the MOSFET when it goes high, and as she comes down, when it goes below the threshold of the gate voltage, it's going to turn off, and we're going to get this pulse, this negative going pulse about 50 milliseconds into pin 3 of the SCAMP board. And then it's going to sense that and turn on the pin 5, make it go high, turn on an LED. Now on my dunk circuit tank, my original one, I didn't use a microcontroller. I actually fed this pulse into a monostable, a CD4538, so there was no microcontroller. I just used the microcontroller here to make it a lot simpler. Okay, so that was my little project using a knock sensor. Now if you're into electronics and you see somebody struggling with a problem, the solution might be simple to you, but it'll be a big deal to them. That's why I started this channel. I'm not interested in getting a very big channel, just a bunch of people to solve problems. So have a look around, see what kind of problems you could solve.